Hello, everyone. Thank you all for joining. Happy to be there. First time in New York, so a little bit stressed. Yeah. To start things up, can I please ask everyone to raise their hand, please, on the room? OK, thank you. All the people that create metrics, create services that send metrics, uses tools to visualize those metrics, keep your hand raised. The other can lower their hands. OK, if in your company there are more than one tool sending metrics or visualizing metrics, please keep your hand raised. Otherwise, lower your hand. If you are working with different teams that send, for example, HTTP server metrics, but they are not sending the same name for the metrics, please keep your hand raised. OK, still few hands raised. OK, thank you all. Last question, if you already know about OpenTelemetry, raise your hand. OK, a lot of people, actually. Thank you all. You may already see where I'm going with those questions. When every team uses its own method to track how things are working, finding a single answer about the health of a system becomes hard or maybe difficult to maintain. Today's presentation is how we got full value of our metrics with OpenTelemetry and Datadog. My name is Alexis Détré. I'm a backend software engineer and a backend guild leader. Guilds in leboncoin is for community of practices, so basically backend communities in leboncoin. As you may have heard, I'm sounding French. It's because I'm coming from France. And yeah, so is leboncoin. Leboncoin is the leading French e-commerce company for second-hand products. It reaches half of the French populations every month. It's a digital cultural icon. You can compare it maybe like Craigslist in the US. You can do a lot of things, like you can buy your house, you can sell vehicles, and even find super rare Pokemon cards, for example. Leboncoin is part of Adevinta. Adevinta is a worldwide company that exists in more than 10 countries. There are a lot of employees, like 5,000 employees in the company, and 25 marketplaces inside of Adevinta, Leboncoin being one of them. The topic of this presentation starts with an ambitious project we've had in Adevinta. The goal was to create more synergies in Europe. Here are the top 5 marketplaces of Adevinta in Europe. Combined, they reach 120 million users every month. So it's quite a lot. But each of those marketplaces are autonomous, and they don't share a lot of things across companies. We tend to develop again and again the same features. 95% of all the features we develop are the same across those companies. When I'm talking about features, I'm talking about, for example, implementing a new shipping providers, maybe a new payment system, or even optimizing the search of the ads. So a little bit like this tree. The goal was to get the best of each marketplace and share developments to create one platform. One platform to serve all the marketplaces, so instead of having 5 infrastructure, 5 different backends, and a lot of different apps, create one shared platform that could be multi-branded with multiple languages and customizable per country and per brand. For people who like visual modes, it could be looking like this. This created a lot of interesting challenges, and today's presentation is not about that project. It's about how we observe that platform. Because yeah, observing shared components across companies is quite a challenge. It's a massive scale, again, 120 million users every month, thousands of people working on those products, and we are part of different companies, part of different countries, and we don't share the same culture. More importantly, for today's topic, we don't share the same technological stacks and tools. For instance, for the backend in Germany, they develop things in Java. They use Spring Boot to generate metrics, and they send their metrics to Grafana. Whereas in France, we develop things in Go. We have our own custom framework to generate metrics, and we send metrics to Datadog. 2 countries and already 2 stacks, and 2 different tools to visualize them. But it gets worse, because in Java, the metrics they generate look like this. http.server.request.count, for example, for counting the number of requests handled by the Java server. And in Go, we generate things with our own custom metric name. For example, $app.response.count, where $app is the name of the application generating the metric. And yeah, those are not equal. Trying to make sense of our telemetry data when all the services send different metric is difficult. For example, here we need to manually aggregate all of our services metric to produce one graph. And yeah, at the end, on the bottom, you can see we sum all of those metric, but with thousands of services across the group, well, it's just not maintainable to do it that way. So a lot of differences between our teams, our countries, our companies, and we follow different conventions. Simple questions like, do we have a higher latency in this country? Or what is the authentication error percentage per brand? Are really difficult to answer. So we gathered the stakeholders, leads, and tried to make sense of our data, making them more uniform. We even wrote an ADR, how should our metrics backend be named, with a lot of iterations, a lot of time trying to make people agreeing on something we created. But this was abandoned quite quickly, because at the end, we were trying to reinvent the wheel. And trying not to reinvent the wheel with a lot of constraints, expectations, and meanwhile, the platform is not observable. Our current monitoring stacks lacks the ability to get a unified view. So we could follow the Java convention. It was quite nice, quite useful. You can already aggregate per services. But yeah, what do we say to Golang developers and Python developers? Should they also follow the Java convention? It felt weird. So we were in need to find standards that everyone would follow and agree to follow. And maybe you see where I'm going. OpenCensus was a standard created by Google and released in 2018. It was a standard to basically document metrics and how things should be named in the metric ecosystem. And OpenTracing was a CNCF project created in 2015 and doing quite the same thing as OpenCensus, but for more focused on traces. OpenTelemetry is the result of merging both of those projects and was created in 2019. OpenTelemetry, since then, is a cloud-native computing foundation project. It's actually the second biggest project in the CNCF after Kubernetes, in terms both of contributions and community engagement. Thousands of companies are contributing to it. And it has been adopted by telemetry big players, like, for example, Datadog, and also cloud providers. OpenTelemetry brings a lot onto the table and is significantly impacting the observability landscape. It starts with clear documentation, basically documenting everything, defining what is a metric, what is a trace, what compose those metrics and traces, for example, tags and spans. But it also defines protocol, how to communicate those things outside of your application to some telemetry vendor like Datadog. But it also brings documents a semantic convention. It defines how things should be named, for example, or HTTP server metrics, or Postgre clients request latencies, those kind of things. And this allows to have consistent telemetry data across stacks, regardless of whether it's sent from Python applications in Germany or from a Java application in France or Golang application in France, whatever. And because there is a huge community already involved on OpenTelemetry, there are on-the-shelf implementation for nearly everything. Okay, why not OpenTelemetry? To make sure all the stakeholders would choose OpenTelemetry, we had to convince them. First, we needed to realize our situation. And OpenTelemetry would allow us to overcome current inefficiencies and limitations to observe the platform. It would, obviously modernize and standardize our monitoring stack to achieve unified observability. But also, because it simplifies the way we observe, and because a lot of things are on the shelf already, or could be reused after being implemented, OpenTelemetry would boost engineering efficiency and allowing more people to be more focused on the product instead of maintaining dashboards or tools or things like that. Okay, we chose OpenTelemetry. How do we migrate to OpenTelemetry? when we have thousands of services and hundreds of engineers that are used to the old metrics? First, we had to learn the documentation, learn the required efforts. So first, we did a lot of workshops to discover, to play, to ingest the documentation, and that's when guilds in leboncoin are useful. We bring all the backend engineers into the same place, and we share a lot of things all together. Really quickly, the realization was simple. Renaming metrics implies really little code and a lot of UI updates, because you can change things really easily in your code, but after that, you have to update all the places where your metrics are used. And we had a lot of support from Datadog. And I think I saw Pejman in the room. Thanks again, Pejman, for helping us, because, yeah, thanks to this support from Datadog, we got really, we could grasp the context where we were in, and how Datadog would react if we send OpenTelemetry metrics to it, what would work correctly and what would not. It provided us with ideas and converted our plan to migrate. When I say there are really little code updates, basically in Java, they use micrometer, and it was really few efforts to generate hotel metrics with it. But in Go, we live in a monorepo, and everyone is using the same libraries. We have common libraries for generating HTTP server metrics, for consuming Kafka events, those kind of things. And the goal was just to import the SDK with nearly no custom configuration, and in every libraries producing metrics, adding a new middleware to observe it with hotel. The goal was to keep the old middlewares, but to add new ones. And you will see why. Then we add explicit switch on each services that wanted to have OpenTelemetry enabled metrics. This switch, when activated, would send both OpenTelemetry metrics and legacy metrics. OK, so we have an implementation. Now we need to validate it. Some team of volunteers participate to validate implementation. And the goal was to compare our different sources of truth. So yeah, we send new metrics when we activate that flag. But the goal was also to compare them with other telemetry metrics we are sending to Datadog. For example, legacy metrics we were sending, but also the APM metrics. Dual running was useful to validate, but doing it at scale with all of our services and thousands of applications would just be super costly, because it would imply basically doubling the number of metrics we send. But it also complicates data continuity. For instance, here you can clearly see we are doing double running, with the light blue being the legacy metrics and the darker blue being hotel. And we are double running, and at some point we stop the double running. But this messes things up. Like, for example, if you have alerts and you configure everything based on that, it can be weird. And having things like clean on-off switch without the double running was easier. So instead of having dual running for every applications, and after validating the implementation, we decided to have clean on-off switch. Basically, enabling OpenTelemetry would disable the old metrics. And we can clearly see here, for example, the legacy metrics on the bottom are stop being sent, and on top, the OpenTelemetry metrics start to be sent. Nice. We have validated our implementations. Now, we have to onboard a lot of people on this project. Like I said, not a lot of code updates, but a lot of UI updates. We need to be able to find all the places where the old metrics were used, and Datadog provides a nice tool to achieve that. Here, in the metric summary, you can just put the name of the metric. So as I said, $app.response.count. I can just put response.count, and the service tag to isolate my service. And then from there, I find the metrics I'm looking for. And when I click on it, I have the list of all the places in Datadog where this metric is being used. For example, dashboard, notebooks, and monitors. Here, for this specific metric, I only have one dashboard. If I click on that dashboard, then from there, I can find all the UI components that uses that metric. For example, here, it's something like this. And yeah, for all the graphs where we want to have data continuation, well, basically, we have to update them, keep the old one, and add the new one. This is very tedious to do, time-consuming and error-prone. So we build community-maintained dashboards. because the metrics will be the same for every applications. Then we can reuse the same dashboards again and again. And a lot of dashboards could be replaced by this, but some of them don't. So for those specific cases, we also had what Datadog called Power Packs. Power Packs allows you to bring some part of dashboard inside other dashboards, basically. This was, depending on the dashboard, quicker than updating all the widgets. Lastly, the onboarding phase also concerned engineering managers and directors, product owners, and things like that. Because thanks to source code parsing, we were able to say, OK, all of those applications enabled OpenTelemetry for those kind of libraries. And with automatic dependency detections, we were able to find whether a given application was using an HTTP server or things like that. So we were able to produce a Google Sheet saying, OK, per library, per services, whether something was impacted, is migrating or is not. And because from there, we can precisely say, OK, these services are owned by those teams, so you have that number of migration to do, and you have a completion percentage. Thanks to those kind of documents, everyone could follow the remaining efforts and progression throughout the migration. Nice. We have a plan. Before everything, let's review it. Basically, we have implementation done and validated. We made a lot of documentation. We did presentations. We did workshops to onboard people. We have a reporting document ready for all the people that wants to follow the migration progression. 80 teams' roadmaps have been impacted by that migration, and it's already prioritized. Nice. It means that 120 backend engineers are ready to migrate nearly 1,000 services. Everything has been tested multiple times. Everyone is onboarded. The plan has been reviewed. We took multiple months to prepare that migration. Imagine, it's a beautiful Monday morning. The sun starts shining. We are at the beginning of the quarter. Now is the time to migrate. Nothing could go wrong. We are so ready for this. Yeah. Right? Well, a few days after the migration, spoiler alert, no. We received a message on Slack saying, hello, I am migrating a service to OpenTelemetry, and there are a few error requests not showing up in the metrics count, though I do find traces for those errors. Is it a non-issue? Well, we spent time with this person to investigate, and indeed, there are no other explanation. He is missing data points in production. And it's not only a few. We found examples during like 5-minute periods where he will lose nearly 30% of his metrics data points for this application. This is not fine. So the situation was too critical. We could not afford to lose or be partially blind in production. And 3 days after starting the migration, we had to ask the 80 teams to roll back, to stop the migration, and the 120 plus engineers to roll back. Because we were not really understanding why. At that time, the sun was definitely not shining anymore. OK, let's take some time and bear with me to investigate. Let's get back to our different sources of truth and compare them again. Everything seems to be normal at that scale. But we are missing metrics, so let's subtract things. For example, the OpenTelemetry metrics and the trace-based metrics, the APM metrics. OK, we are losing metrics, so we expect this number to be negative, but it feels like it's not much, less than 1%. It's still existing, but where? Maybe we can find specific period of times where things get worse. Here is a good example. As we can see here, the numbers are obviously different. They do not match anymore. And we can clearly see loss of data points in OpenTelemetry metrics. Still no clue why this is happening, though. We have to find correlation. Bear with me, next slide is key. Our breakthrough came from this view. On top, you have the cumulative subtraction between our source of truth. And since we are losing metrics, this number is negative, as expected. At the bottom, we have a graph showing the number of instances a given application have running on the same host. And we can clearly see something here. Every time the number of instances exceeds 1, we start losing metrics. And every time it gets back to 1, we are not losing metrics anymore. And this is happening every time. We spent hours investigating, partially being able to partially reproduce locally. We reread again documentations, and we found this. So it's a long sentence, let's shorten down. What Datadog is saying is you have to set the temporality preference of the OpenTelemetry implementation to delta, because setting it to cumulative may discard some data points during application startup. If everyone has understood what this means, nice. We were not. Hopefully, they have clear documentation and a precise guide on it, on their documentation about this. But welcome to the amazing world of aggregation temporality. Basically, it's one of two things. It's either cumulative or delta. It's an OpenTelemetry configuration on the SDK that you can configure locally on each application. And by default, for OpenTelemetry, it's cumulative. It means it records everything since the start of the application, and it sends basically the sum of everything since the start. Whereas, you may have understood it now, Datadog is expecting delta. You need to send the delta between two reports instead of sending the aggregation. Well, this explains things, but why we didn't see it during the dual running? The reason we didn't see it was because the dual run was made on some small services, and the probability to have two instances running on a huge amount of hosts was low. Whereas when we ran the migration, heavily used services started to migrate. And the probability that two instances of heavily used services running on one given host was way higher. And the situation was happening specifically in that case. Boom. OK, we learned something here. Back to the plan. We had to reprioritize everything to the next quarter. It took us time to double and triple check everything again, re-enabling dual run on some heavily used application. But here we go. We are planning the migration, and, well, we did it. 2 quarters later, the migration was done. All of our services sending metrics, HTTP server metrics, HTTP client metrics, Postgre client latencies, and things like that, all migrated. Yay. Well, OK, let's go through the benefits of that migration now. This one wouldn't surprise anyone. We did everything to achieve unified observability. So this one is expected. We don't need to manually sum everything anymore to have a unified view of our services. We only have to use one metric. We are now able to follow nearly every kind of services applications, Kafka consumer, Kafka producer, Postgre listeners, all those kind of applications are now using one metrics and OpenTelemetry convention, regardless of which countries produce those metrics, regardless of which stacks, regardless of which teams and which tool you use to visualize those metrics. Nice. Individual contributors are maintaining shared dashboards and power packs, reducing duplication and maintenance for all the backend guilds. But as I said, this one was expected. We did that to achieve this. There are other benefits you may be not expecting. Because a lot of people got involved, they started to challenge their alerting, their dashboards. Overall, we got a lot of more discussions around telemetry in our company, and not only for backend engineers. For example, other communities starting to spend time on those topics, and projects like sending OpenTelemetry metrics from Android app got started. Nice. But it gets better. Because we spent so much time trying to make sense of our telemetry data, we started following metrics volume, team usage, also making sure we don't exploit the costs by a huge cardinality. We started creating our own OpenTelemetry registry for custom tags to document and review them. We discovered some low-hanging fruits and optimized metric usage. But maybe you want some numbers. A reduction of 30% of our total metrics being sent to Datadog. And of course, a reduction of the costs. This was unexpected. Nice. What are the next steps now? Well, the migration of the metrics are done, but there are other pillars to the telemetry system. So We will be thinking about migrating logs, but as of now, our focus will be more on traces. We already know that this will create some challenges because Datadog is relying a lot on the APM and ddtrace library to achieve that. But they released recently something regarding OpenTelemetry collector, so we may be able to migrate soon. But more importantly, telemetry-as-code, since the beginning, would have allowed us to go way quicker on that migration. And now that we are migrated, we can say, okay, let's not worry too much about this, and we don't need telemetry-as-code, but no. OpenTelemetry is a living project, and the semantic convention is living. There are addition, updates, deletion, deprecation, and it's part of the semantic convention. It's already happening. We need to stay up to date, and telemetry-as-code will definitely help us reducing the maintenance costs and complexity over time. Datadog is even providing a Terraform module to achieve that, so we may try it soon. Lastly, if I have to create one slide to resume them all, the first thing I'm going to say is we can only improve what we measure. And this is true for so many things, like, for example, being able to follow the metrics we send, like the volume of the metrics we are sending, finding correlation during the incidents, allowing, I don't know, teams to improve their services. And without those metrics already being sent, it would be so much more difficult to achieve what we've done. Telemetry is a shared responsibility. It's not only a back-end situation or an infrastructure guy's problem. It's for everyone. It's for the whole team and even the whole organization. Directors are to have to understand how it works, not internally, but how to observe the health and how to follow whatever things is working on it. And embedding everyone on that migration allowed them to be more responsible on how they are using those tools and what is possible to do with them. Standardization is the foundation of unified telemetry. And yeah, now you know it, OpenTelemetry is the standard you are looking for. And for us, at least, telemetry-as-code is the future. We wrote a Medium article about this, and if this story got you interested, you can flash that QR code to see it. If you did a similar project, we would love to have your feedbacks. Or maybe you already are in the future from us, like, for example, doing telemetry-as-code or things like that. Please reach out to us if we can learn from your migration. Thanks a lot. Thank Paul, which is in the room. We did the migration together. Thanks the leboncoin team, which is also in the room and supporting me. Thanks Datadog and Giuliano, I see you in the room also, for the support. Thank you all for listening, and I guess we have time for questions now. Thank you.
Thank you very much for the talk. If you have a question, please step to the microphone in the center.
Hi, with the OpenTelemetry being kind of a newer project, there's a lot of extensions, a lot of contributing libraries that are maybe not as, are more in the beta phase or are not fully stable. I guess with the widespread languages and stacks that you guys were using, do you recommend waiting until there's more stability for some of these? Because I know logs and stuff is a little bit difficult to integrate immediately and things like that. What would your recommendation be?
While doing this presentation, I discovered that we were in the beta phase of the Golang implementation, like the SDK of OpenTelemetry was in beta phase. And during that AGR time where we were thinking on reinventing the wheel, that's when the Golang SDK for metrics and traces went from beta to production ready. But for logs, I guess it's not ready yet. And I don't know if for other languages it's in production ready state yet. But the OpenTelemetry documentation is quite clear on this. First, the API, the definition of things for metrics, for spans, for tags, and things like that, they are since a long time ready for production, stable things yet already. And the implementations, they are moving because, yeah, as I said, it's a living project, but they're quite clear on their status page. Every time you are seeing, for example, HTTP server, convention, things like that, they're saying, okay, it's experimental or it's stable. So I would definitely not recommend using in production things that is not stable yet. But yeah, well, it's written on the documentation.
Thank you.
Thank you for the question. Any other questions? Don't be shy.
Yeah, one sec.
Hi, thanks for the presentation, very insightful. We at our company are in a very similar journey, and not long ago we had to make a decision between using OpenTelemetry across the board, across all of our platforms, or using the native Datadog agent for collecting telemetry data and send it up to Datadog. And we're creating internally an observability pipeline to interface between the two points that I mentioned. I guess my question to you is, at any point in time, have you considered or waived in, based on your requirements, using the Datadog agent for collecting that, or how's that process? How's the experience there?
During the incident we had in production regarding the loss of metrics, we went through a lot of emotions. And at some points, we may have put into questions the agents. Spoiler, it was not his fault, but at some point we were like thinking, oh, I don't understand what is happening. So we tried the OpenTelemetry collector, and the error was still there. But the situation is, for OpenTelemetry, Datadog is doing a lot of things. It's I think we can say it like this. It's obviously quite newer compared to the existing agents. They have an OTLP endpoint inside the agent. And recently, I think it's like a few months ago, they released an official collector inside of the agent. I guess for metrics, it doesn't really matter because the exporter configuration on the OpenTelemetry collector for Datadog is working well, I guess. And the agent also is working well for metrics. But for traces, it gets a little bit less clear, at least for me, and I didn't work on the migration yet, so I'm not really sure what to say about it. Pejman is in the room, so feel free to ask him questions about this. He will be definitely more skilled than me to answer exactly the differences in traces for those kind of collection. But yeah, I guess the Datadog documentation was clear also on this. So I think we tested both using the agent and the collector. At the end, it's kind of similar for us. Thank you for your question. Someone has a question.
Please make your way to the microphone. Thanks.
Yeah, I wasn't completely clear on how you got the reduction of 30% once you switched to OpenTelemetry. How did that come about?
Yeah, the 30% reduction in the number of metrics sent to Datadog and the cost it reduces was...
that 30%, that was cost or the number of metrics?
It was costs, but yeah, basically the number of metrics being sent is related to the cost we are paying for those metrics. So I don't know if we reduced the 30%. I know we are reducing 30% of the cost, but I don't know if it's linear reduction of the number of metrics. But at the end, we send less metrics to Datadog. At least the cardinality of the metrics reduced, because when we introduced OpenTelemetry to the people in leboncoin, we asked them to follow the convention. And we have already on the shelf implementation that have a limited amount of tags. And the old implementation allowed people to customize and add a lot of things into the metrics. And the reality was some people were not aware of those tags being sent in their applications, or they were aware of it, but when they migrated, they were not using those tags anymore. And by having more people involved in telemetry and having more governance on telemetry in general, we discovered that there were a lot of, I would not say misusage, but a lot of usage that were not efficient. And by kind of asking or forcing people to document the tags they want to have. We didn't discourage people to have custom tags, but we asked them to document them and to put them in the registry we created. And by doing that, it makes the people think more about, do I need those tags, and what that tag means for my product. And some of the tags got removed, and that's when, at the end, we were able to reduce the number of cardinality of the metrics, and at the end, the number of metrics being sent. Also, there is a feature in Datadog that allows you to discard the tags being, I don't know if it's ingested or indexed, but I think it's indexed. When Datadog is ingesting tags, then you can later say, okay, I don't want this tag to be indexed, and it doesn't count as a queryable tag. And when we spend time working on metrics volume and things like that, we, at first, added a lot of useless tags to make sure we were using it correctly. But at the end, we disabled those tags, and we disabled a lot of tags that were not useful for us. So it also allowed us to reduce the cardinality of the metrics and, at the end, the costs.
Any other questions? Step right up.
Did you have an approach for custom metrics that needed to maybe be in one or two services? Like, did you allow for that, or are all metrics being generated through these shared libraries in a standard format, and you say you get what you get?
Yeah, it's definitely it's a really nice question. We mainly focused here on the backend guild metrics and the metrics supported by the common libraries we were maintaining inside the backend guild. So, like I said, like HTTP server metrics, HTTP clients, those kind of things. But a lot of teams have custom metrics for observing their products. Like when you deposit an ad, like it's not something that is documented in OpenTelemetry, of course. For those metrics, the plan is to allow those people to have a dedicated namespace for their product. For example, ads for ads-related metrics, or transaction when you do payments, those kind of things. On that part, we are on the middle of doing that migration for the custom metrics, like the teams metrics. So we are writing documentation on how to choose that namespace correctly. And then from that, the rest of the metrics doesn't really matter to us, as long as the teams are understanding what they're doing with it. So the goal will be to document also those metrics and tags added. But the most important thing is to have useful namespace to avoid payments counting on vehicle and transaction counting on whatever else and being wrongfully added together. So yeah, to answer your question, we didn't ask all the people to migrate those things at first because it's super difficult to correctly choose the new names and things like that. So they have to really ingest the documentation more. But we are doing some recommendation on naming and stuff.
All right. Thank you, Alexi.
Thank you all.